class, this is Dr. Karsten, and today we are doing lesson 22, and this is from module 5 of grade 4's EngageNY Math program. So today we are just building on what we have been doing. We are going to continue adding and subtracting fractions. All of our fractions today are going to be less than 1 that we are adding or subtracting. And what's changing though is that the number that we are adding or subtracting from is going to be a whole number, and they're going to be greater than 1. They're going to be 2, 3, 4, they're going to be bigger numbers. But we know what we're doing, we've been doing this, so I know that you are all going to do a fabulous job on this. So let's just jump right in and do some sample problems, and then we'll go into the problem set and do a few there. Okay, so I'm going to start with 2 plus 1/2. So if I want to add 2 plus 1/2, I want you to think about what we're saying here. We're saying that we have 2 wholes, and we're going to add a half to that. So let me go ahead and let me model that using a tape diagram, and that might be a nice, easy way for us to do that. So for this, the first thing that I'm going to do is I'm going to model those 2 wholes. And you can see here I have 1 hole and I have 2 holes. And I'm going to go ahead and show that this is 2 holes. Now if I have 2 holes there, for me to know how big to draw my half, let's go ahead and decompose these into halves. So to take 1 hole and turn it into halves, I'm just going to go ahead and cut that into 2 equal pieces, or partition it into 2 equal pieces. And I'm going to do the same thing here. So now I know the correct size to draw when I'm adding on a half here. And I'm going to go ahead and do that. So here's my half. And now what you can see is that we have 2 1/2. So when we add 2 plus 1/2, we end up with 2 1/2. All right, so that one was pretty easy. What about if we want to subtract? So here, let me slide this up so it's not distracting us. And let's think about this. Let's say I wanted to take 3 and I wanted to subtract 1/4 or 1/4 from that. If I wanted to do that, let's use a tape diagram again and see how we would do that. So let me start, and I'm going to go ahead and draw 3 holes. And I'm going to try and do this as neatly as I can. They're okay. Not perfect, but okay. Now I'm just going to go ahead and model off right here. I'm just going to mark this or bracket this off so that we know that that's 1 hole. So you can see I have 1 hole, 2 holes, 3 holes. So now what about if I wanted to subtract 1/4 from that? What should I do? Well, what I'm going to go ahead and do is I'm going to go into this third one, and I'm going to turn that into quarters. Since I want to subtract 1/4 or 1/4, it would be really helpful if I decompose this into fourths. So now what you can see is that I have 2 that are still wholes, they're completely whole, but this one I have decomposed into fourths. And now what I can do is I can say, well, let me get rid of one of those fourths. So what am I left with? I'm left with 2 wholes, and then here I have 1, 2, 3 fourths. So when I take 3 and I want to subtract 1/4, I end up with 2 3 fourths. So what you can see is that what we really did was we pulled these 3 holes apart into 2, and then this 1 hole we decomposed into smaller pieces. We renamed it into fourths basically. And that's how we were then able to take away 1/4. If we left it as a whole, we couldn't do that. Remember how we've been talking about having the units be the same when we're subtracting? Well, by taking this and turning it into 4/4, we were able to take away 1/4, and that left us with 3/4. And that's really what we did here. Let's do another one like this, a similar one to that one. Let's do 3, and let's subtract from that 2/3. So again, I'm going to start by drawing the tape diagram. And I need 3 holes because I'm starting with the hole number 3 there. So I'm going to start with 3. I'm going to do my best to try and make them nice and even. And then I know ultimately I want us to bracket off the whole thing, but for right now, just because I want to keep things kind of neat, I'm just going to bracket off 1 to show that this is 1, because now you know that this is equal to 1, this is 1, and this is 1. So you can see that we have 3 wholes. But again, I need to have the denominator be the same. I don't know how to subtract this right now, because I have 3 wholes, which is really 3 over 1, and I have 2/3. Well, this has a denominator of 3, of thirds. That's not going to work for this problem. So what I need to do, oops, sorry about that, I giggled this, is I need to decompose this one over here, this last whole number. So I'm going to leave it as 2 here. So I have 1, 2 wholes. But then I'm going to take the 3rd whole, and I'm going to turn that into thirds. So I'm going to model that using dotted lines. So now what you can see is that here I have 3/3. But I need to now subtract 2 of those. So what I did was I started off with 3 wholes. I decomposed it into 2 and 3/3, which is still 3 wholes. It's just written a different way. Just renamed it. And now I need to take this 2/3 and subtract it. So I'm going to take those off. And now what you can see is that I still have 2 wholes and I have 1/3. So when we did this, the answer is 2 and 1/3. And I'm sorry I'm not like doing everything vertically for us. Horizontally. But I think this is starting to make sense for you probably. So let's take a look at another problem, and then I'm actually going to show you a little something slightly different after this. Another way of doing this that might work for some of you a little better. It's like a little trick way. But let's take a look at another problem. So let's look at, oops, sorry about that. You know what, actually I'm going to start on a fresh page because I want to have room, because I might do this one a couple different ways. Let me slide this down. Here we go. So I'm going to do 5 minus 1/4. So for this one, I'm going to start off doing it with a tape diagram. But then what I'd like to do is use a number bond. And for those of you who really like our number lines, we're going to do a number line. And then I'm going to show you my trick. So let's start off with doing this with the tape diagram. And what you're going to notice is that my tape diagram is going to have to get much longer, because I have to be able to fit 5 holes. Imagine that we were doing like 100 minus a fraction. That would be a lot to be drawing. So let's just kind of keep that in mind. Okay, so I need 5 holes. So let me do my best to try and decompose this, or split this up, or partition this. So you can say I have 1, 2, 3, 4, 5 holes. And again, for our purposes, I just want to show what 1 hole is right now. So since I want to subtract 1/4 from 5, I need to decompose this last one into fourths. So I'm going to keep the first 4 as they are, as wholes. But then this last one, I want to decompose it into fourths. And if I do that, I'm going to cut it into 4 pieces, or partition it into 4 pieces. So I end up with 4/4. So let me write that. So I started off with 5 holes. We decided to make it 4 and 4/4. So let me just go ahead and really quickly do that with a number bond. So if I started with 5, and then what we did was we turned it into 4 and 4/4. And the reason we did that was now I can subtract this 1/4 from these 4/4. So I hope this is starting to make some sense to you, and we're kind of doing it a couple different ways. So let me get back over here. So now what I have to do is I have to subtract that 1/4. So I'm going to go ahead and subtract 1/4 from that. And what I'm left with is 3/4. So now what we know is that our answer is 4 holes and then another 3/4. So 4 3/4. Now the way I could show that over here is that we have turned this 5 into 4 4/4. So we split it, we put 4 over here, we put 1 whole over here, 1 whole is equal to 4/4, numerator, denominator match. And now what I could do is I could subtract that 1/4 from this 4/4. So I would have 4 4/4 minus that 1/4. Well, that would leave me 4, and 4 minus 1 is 3. Oh, I'm going too low. Let me slide it. 3/4. Okay, so we have done this 2 ways so far. We've gotten 4 3/4 2 ways. The first way we did it was we did it with a tape diagram. The second thing we did was we related our tape diagram to a number bond. And then we subtracted because now we had common units or common denominators. We had our units were the same, our denominators were the same. So I want to show this to you now one more way. Well, one more way and then my little trick way. So what I'm going to do is I'm going to use a number line. Some of you guys really like the number line. If number lines confuse you, feel free to fast forward through this part. You do not need to watch this right now. As long as you're comfortable with one of these ways of modeling it, I'm okay with that right now. I do not want to confuse people. So I'm going to make a really long one, and the reason that I need to make this so long is that I have to go from 0 all the way up to 5. And this is going to explain something to you in a second. So let me see if I can try and do a good job. Okay. So here we can see I have my holes. 1, 2, 3, 4. So I have all the way up to here is 5. And then what I have to do is if I want to subtract a 1/4 from this 5, because remember we're doing 5 minus 1/4, what I have to do is I'm going to have to show my 4ths in here. And I'm going to go ahead and do that with a purple pen. And I'm going to go ahead and just kind of do dotted lines to show that I'm decomposing this 1 hole here into 4ths. And then what I want to do is I want to show that we are going to the left. We're going that way. We are subtracting 1/4. So I'm going to do my little arrow, and I'm going to show that I subtracted 1/4. And where did I end up? I ended up at 1, 2, 3, 4, and 1, 2, 3/4. So 4 and then 3/4. So right there, that is 4 and 3/4. Now, here's the thing. In the book, they are not going to do a number line from 0 to 5. It just doesn't make sense. Imagine again that we were going up to 100. Are you really going to make a number line that like stretches across an entire table? No, we're not going to do that. So what they do, and I'm going to do this physically, they zoom in on the part that's interesting. So watch what I do. They just zoom in, and it's going to be a little blurry, but they zoom in on this part like this. So that's what their number line will look like. So let me put it back down and do it again. So instead of doing this, they just zoom in on the important part of it. They get nice and close on that important part. So let me redo this. Let me redo this one by zooming in. So I'm just going to zoom in on this part of it. So instead of drawing the whole number line, let's just draw the important part of the number line. So we're just going to draw from 4 to 5. And we know that it goes on in both directions. So we're just taking this and we're going to put it over here. So again, we started at 5. And then in order to show that we are subtracting 1/4, we have to decompose between 4 and 5. So we did that. So now it's all, those are 4ths. And now I'm going to model subtracting 1/4, which gets me to 4 and 1, 2, 3/4. So it's 4 and 3/4, and that's our answer again. And put a nice dot here for us. Okay. So what we did was we modeled it a few different ways. I hope that this is making sense, that I took this and then I zoomed it in over here. And that's how it'll be in the book if you are doing this way. If you are going to model using a number line, you do not want to go 0, 1, 2, 3, 4, 5. You just want to go from 4 to 5. You just want to work in the area in which you're working. Okay, so now let me show you another little shortcut that I enjoy teaching students who really get a little confused with this stuff. It's another little trick that you can do. So let's just review something that you all know how to do. Let's do a basic subtraction problem, or let's just work with a basic subtraction, because today it's a lot of subtraction. And I'm going to do another video that focuses in on this, but I'm going to give you a taste of this. A few of you have already had a little taste. So let's say that I am taking 2, and I want to subtract 5 from that. What you all have learned to do is you have learned to regroup, right? Or to rename, actually, I'm sorry. But to rename things. So instead of, or the way that your parents are going to do it, they're going to say that they borrowed. And a lot of you guys know that because your parents have taught you that. But look, if I have 2 ones, I don't have enough to subtract 5 from that. Think about it. If I have 2 fingers, I can't take away 5 fingers or give you 5 of my fingers. So what I need to do is I need to go over here, and 3 becomes 2. And what we're going to do is we're going to move 10 over here. So the 2 becomes 12. And I know you've done that. We've done that with our tables and everything, and place value tables, and we've really modeled this a lot. So I know you all know how to do this. And then I'm going to take that 12 and I'm going to subtract 5. So remember, we took one of these 10s, we moved it over, and it became 10 ones when we did that. And so then we added it to the 2 we had, so we have 12 minus 5. And we have 7. And then we just do 2 minus nothing is 2. Okay, so I know you know how to do this. Well, with fractions, we're kind of doing the same thing. And again, if this doesn't make sense, don't stress. But I know that this might help a few of you. So let's go back to that last problem where we were doing 5 minus 1/4. Well, if I want to subtract 1/4 from that, you can see I have no fraction over here. So another way that I could do this, I could rename this. And again, I could take that 5 and turn it into a 4. And then I'm going to move 1 over. And I'm going to decompose that 1 over here. Just like we took one of these 10s and moved it over and turned it into 1s, let's take one of these 1s and turn it into 4ths. And I know that you know that 1 whole is equal to 4/4. So I can just put 4/4 here. So again, I just took that 1, I moved it over, but I wrote it as 4ths right off the bat, because I know that. And then I'd have 4/4 minus 1/4 is 3/4, and 4 minus nothing is 4. Okay, I know that that's like getting a little crazy, but it might help some of you. Let's do one more this way. But again, we're really during the lesson today going to focus on the other ways that we did it. But let's just do one more, just for fun. So let's say that we had 7, and I wanted to subtract 2/3 from it. So again, I could take that 7, and I could make that a 6, and I'm going to take that 1 and move it over. So just like we know that 7 can be 6 and 1, right? Now what am I going to do with that 1? Well, I want to turn it into thirds, so I'm going to have 3/3. And so you can put that over here. So 7 becomes 6 and 3/3 because 3/3 is equal to 1. Now I can just say 3/3 minus 2/3 is 1/3, and 6 minus nothing is 6. Okay, that might help some of you. I'm going to do another mini lesson on that with you, because for some of you, I know you're really struggling with the models, and I think that having kind of an algorithm almost for this might be helpful for you. If it isn't helpful, don't do it right now. You don't have to. For now, you can still be just using the number lines or the algorithms, the number lines or the number bonds or the tape diagrams. And that's fine. So let's do a couple examples from the problem set, and then I'm going to cut you loose to do your own work. So here we go. So let's take a look again. We're in problem set of lesson 22, and I'm just going to do a couple of these with you. So they're kind of nice, and to warm us up, they're gonna start us off with addition. So I'm going to use a tape diagram because it says draw a tape diagram to match each number sentence and then complete the number sentence. So again, let's do this the way that we've been doing this. So I have 3 plus a third. So the first thing that I want to do is I want to draw 3 holes. So I'm going to go ahead and do that. And then what I want to do is I'm going to go ahead and mark this and show that this is 3 holes. And now the thing is that I need to be able to know how big should I draw that third that I'm adding on. I have 3 holes, I need to add a third on. Well, let's decompose these into thirds to see that. And you can just do one of them, or you can do all of them. And there you can see, so now I can see that what I need to draw on there is a third, and it's going to look about like that. And then I can mark it off. I can label it or bracket it off. So now what you see you have is you have 1, 2, 3, and a third, and I can write that. So now I'm going to go ahead and I'm going to model 3 minus a quarter. So let's do this one also with a tape diagram. I'm going to start with 3 holes. Oops, and that one got a little narrow, sorry. It's because I realized I wasn't leaving myself enough space all over the place. So I'm going to have, this is going to be partitioned into 3. And again, for my purposes, I would rather just show you what 1 is for now. Just because I want to keep this nice and neat the way that I've been showing it to you. You could, of course, label all of this as 3 instead. But this is clear, I have 1, 2, 3. And then since I want to subtract a quarter, what I need to do is I need to decompose that into quarters. And there are 4 quarters. 4 make up 1 whole, we know that, because the denominator is 4, and that represents the number of pieces or units that make up 1 whole, or fractional units that make up 1 whole. So I'm going to go ahead and do that, and I say I have 1, 2, 3, 4. And now since we're subtracting, well, first let me label this as 4/4. And then what I'm going to do is I'm going to subtract one of them. And what are we left with? We're left with 2 wholes, and 1, 2, 3 fourths. Okay, so I'm going to write that. We have 2 and 3 fourths. So I am going to let you guys, for part of your work, do B and D on your own. Oh, we're like so crooked, it's killing me. There we go. Okay, I'm not going to do problem 2, and I don't want you to have to do it either. I think you guys understand the number bonds, and I find that those problems right there tend to throw you off a little, even though you're really good at doing number bonds. So let's jump into problem 3. So problem 3 starts here on this page and then goes on to the next page. So let's take a look at this together. And we're going to do a couple together. So this one says, solve using a number bond, draw a number line. Oops, I want to switch back to my black pen, totally. Solve using a number bond, draw a number line to represent each number sentence. The first one has been done for you. Again, I am okay if you guys want to continue using your tape diagrams also to model this. I don't have a problem with that. But in the meantime, let's go ahead and let's do this one using the number line. So if I wanted to do this using a number line, again, I really want to zoom in on the interesting part, the part that the answer is going to fall in. So instead of doing 0, 1, 2, now for the first one, I am going to go ahead and do the whole thing, but then we are going to zoom in. So let's go ahead and let's model this with a nice long number line. And then we're going to zoom in. So we have 0, we have 5, then we have 1, 2, 3, and 4. See, so now we're really only interested in this part of it, between 4 and 5. We're starting at the 5. We want to model subtracting 2/3. So now what I know is I need to partition off between 4 and 5 into thirds. So I'm going to go ahead and do that. And again, I'd like to maybe use my purple pen to make it stand out. And then we can go ahead and model that. So we're going to go subtract 2/3. These are each a third, 1, 2, 3. So we're going to go 1, 2, and this is where we're going to land. And we're going to model subtracting 2/3. But you can see like all the actions happening up here. So another way, well, let's do the number bond since we have all this. So what you can see is that we started with 5 holes. So I'm going to draw that right here. And then what we did was we left 4 of them alone, but we took this last one and we turned it into 3/3. So that's a nice way to show the number bond and what we're doing. So let's take a look though, and then of course the answer would be 4 1/3, which we didn't finish out. Sorry about that. Because we have 4 wholes, then we have 1/3. So let me write that in here. And that's because we have 4 3/3 minus 2/3. Well, 3/3 minus 2/3 is 1/3. So that's where our 1/3 came from. So now though, let's take this and let's zoom in, right? Remember how we did that? So I just need that 4 and that 5. And now what I can do is I can go ahead and I can show my thirds. So I have 1/3, 2/3, 3/3. I'm starting at 5. And remember, we're going down 2/3. I'm going down 1, 2. This is where I want to land. And I can model that as minus 2/3. And then what do I see? I have 4 and 1/3. Okay, I'm going to do one more of these with you. Or actually, yeah, I'll do one more with you. And then you guys will try one of these on your own, and then you're going to do a lot of work in number 4 on your own. Okay, so for this one, we have 7 minus 3/8. And again, if I wanted to show this with a number bond, I could say that I'm starting with 7, but then I'm going to take and put 6 of them here and 1 of them here. Well, what's that 1 going to be? I have to make it 8ths. So I'm going to have 8/8. And then what I now know is that I have 7, which becomes 6 and 8/8. And when I do 6 and 8/8, right, minus 3/8, well, I can just take 8/8 minus 3/8 and I get 8 of those pieces minus 3 of those pieces is 5 of those pieces. So I'm going to be left with 6 and 5/8. Let's model that on a number line. I'm going to do the zoomed in kind. So I'm just going to have from 6 to 7. And we're starting at the 7. And since we are talking about 8ths, we are going to keep the first 6 just as individual units, right? They're all going to be units, wholes. 1, 2, 3, 4, 5, 6. But between 6 and 7, what I want to do is I want to decompose it into 8ths because all my denominators are 8ths. So let me do the best job I can. I hope I'm doing an okay job there. Okay. So now I have 8ths. 1, 2, 3, 4, 5, 6, 7, 8. So now, oh, it's crooked again. I'm just going to turn the paper this time. Okay, so now we're starting at the 7. We're subtracting 3/8. So we're going to go 1, 2, 3. And we land right here. And we're going to model that. Minus 3/8. And what we have is 6. And then we have 1, 2, 3, 4, 5, 8. So right here is 6 and 5/8. So again, that's the zoomed in version. Okay, so really quick, here it says for number 4, complete the subtraction sentences using number bonds. So I hope we're kind of feeling pretty good about our number bonds right now. We've been modeling them. I think you've got them. I'm just going to do 1 or 2 here, and then I'll let you guys kind of work through the rest on your own. So let me first make sure that we are, I'm just going to adjust the camera a little bit so that we are straighter. I don't know how it got knocked out again. Okay. So let's look at number 3. Oh, maybe this will help too. So let's look at number 3. So if I want to subtract 1/10 from 3, well, how am I going to do that? Well, what I want to do is I want to take my 3 and I want to go ahead and decompose that. I want to leave 2 wholes, but I want to take that third whole. Remember, 3 is made out of, 3 pieces. I'm going to leave 2 of them whole, but this one I'm going to go ahead and decompose. Well, what should I decompose it into? Since my denominator is 10, let's decompose it into 10 tenths. So really what we just did was we took 3 and we said put 2 over here and 1 over here. But then we took that 1 whole and we decomposed it into 10 tenths. So now we can take that And we can subtract 1/10 from that. What's 10/10 minus 1/10? It's 9/10, right? If I showed you that like this, 10/10 minus 1/10 is 9/10. But I still have my 2, so don't lose that 2. So you're going to end up with 2 and 9/10. All right, let's try another one. Let us do, let's go ahead and try B. So for this one, we're starting with 5 holes, and then I'm going to put 4 of them over here. So if I have 5 and I put 4 holes over there, that means I have 1 hole left here. But I don't need holes, I need fourths because I have fourths there. So I'm going to make it 4 fourths. So now I have the same units, I have the same denominators. So what I'm doing is I'm doing 4 fourths minus 3 fourths. So I have 4 and 4 fourths really, minus 3 fourths. Well, now I can do that. I can keep my 4, right? I'm keeping him, but I'm going to then take 4 fourths minus 3 fourths, and 4 minus 3 is 1. So we have 4 and 1 fourth. And that's what we're going to write in our answer. All right, I'm going to do one more, and then you are going to be off on your own. And let's jump up to the last one. Let's take a look at F. So here we have 29. Oh my goodness, you so do not want to be drawing tape diagrams and number lines and things like that at this point. So let's take our 29, and let's go ahead and let's make a number bond and show that we are going to have 29 here. We're going to put 28 of them here. We're going to have 1 left over here. But I don't want to write 1 because 1 isn't going to help me. I want to turn that 1 into 12s. And what I know is that 1 is equal to 12 12s. So I'm going to write 12 12s. So really this is 28 plus 1 is 29. All right, so I'm going to keep my 28. Nothing's happening to that 28. But now I have 12 12ths minus 9 12ths. Well, 12 of this size pieces minus 9 of those pieces. 12 pieces minus 9 pieces leaves me with 3 pieces. And what size pieces are those? Those are 12ths. All right, I hope that this is making sense for you. Again, I showed you that other little thing, which you could have done here. It's basically what we're doing, right? When I showed you that before, that little trick where I would turn this into 28 and then next door put 12 12ths. It was a little preview of what we're going to be doing, but for now I think you guys can probably manage this. I will see you in our Google Classroom tomorrow, so you can ask me questions there. All right, so I hope this was clear. I think you are going to do great. If you need to still use the models, that is fine. All right, so have a great night, and I will see you tomorrow morning.